Hello everyone, this is Ashank David, and in today's class, in today's live session, we are going to talk about, again we will continue from DSA placement series, as we were talking about our previous concepts in DSA placement series. We will continue from there. And in the last live session, I was doing queues data structure, where we have discussed about how queues work and how queue arrays are useful for us. Now, in today's live session, we are going to talk about another data structure, and today we will start with the concept of linked list. And before I start with this, I would like to first tell you about the prerequisites which are required in order to learn about this concept of linked list. Number one point, you should know how your DMA works, dynamic memory allocation. You should know how pointers work. What are pointers, what are the different types of pointers. So if you haven't watched those videos yet, or if you don't know about the concept, I will give the link also in the description, as well as you need to you can go ahead and go to our channel and then learn about pointers and dynamic memory allocation. We have already created the videos on that. So the prerequisite of this live session is that you should know about dynamic memory allocation and pointers. This much should be enough. One more thing, object oriented programming, because object oriented programming is the only way that we are going to solve our problems into DSA in C++, rather than solving it with structures or unions in C programming. And this is C++ DSA live session, so we are going to focus on to C++. So without any further ado, let's get right into the concept, guys. And if you haven't liked and share and subscribe to our channel Coders Arcade, please do subscribe and share with the other people. You want them to also see and crack DSA for placements. So let's start. So here today, let us start with linked list. And to do that, let me just switch on to our notes, and let's understand about what exactly is our linked list. So here let's start from what is linked list. So guys, we are talking about the concept called as linked list. So this is our main concept that we are gonna talk about, and let us see. So what is a linked list? Linked list again is a type of data structure. So it is a data structure. It comes under the concept of DSA. It is a data structure. What kind of data structure it is? It is a linear data structure. Linear data structure. Why do we call it as linear data structure? Because like an array, we store many different types of, like many homogeneous data into one place in a linear format. Very similar to that, we also place our data into this data structure in a linear way, in a linear structure, and that is the reason why it is called as linear data structure. That is what it is, our linked list. So this is the main concept, guys. Linked list, why do we use it for? Let us understand. So first of all, if you know about what are arrays, you might know about how the arrays work, right? So if we are talking about arrays, there are a lot of things that you need to be considering. So let us say this is our array, and in this array based on 0 based indexing, 0, 1, 2, 3, 4, for example, this is our array, and let us say some numbers are stored or some data is stored inside our array. Let us say 10, 20, 30, 40, 50 is stored right now. Now let us say there are so much complications in arrays when you try to solve a problem, when you need to solve a problem in a linear data structure. Now array is also a linear data structure. Array also comes into a data structure. It's a type of collection. Similarly, linked list is also a type of a collection. So here we are talking about arrays now, and like I wanted to tell you about a little bit of pros and cons of arrays and compare it with linked list, so that you understand what exactly is the difference between arrays and linked list, and why we are using linked list in this case rather than array. So let us talk about that. So first of all, this is an array, for example, you see. Now I said that I want to, let us say, add one more element here. Let us say we are adding 100. Okay, let us say I want to add 100 in between of 20 and 30. What I need to do, see the problem, the very first problem with array is that the size is fixed. This size is fixed. So basically here no more space is available, so we are saying fixed size. This is our main thing in arrays. We know this, that the size is always fixed. How we declare an array? We declare an array like this, so int arr, and then here we give the size, correct? This is a size which is fixed, and that is the reason we say the size of the array is always fixed. This is one problem with an array. So let's say if I wanna add 100 in between of 20 and 30, then what I need to do is I need to shift the element. So that means this 50 will come out and it will get deleted, and then all the elements will get shifted to right hand side or towards the end of the array one by one. In this case 100 will be able to, you will be able to store 100 in between of 20 and 30, but the problem is that the last element gets deleted. Why this happens? Because the array size is always fixed. And if you want to increase the size of array, then you need to explicitly use DMA, dynamic memory allocation. In C programming you might have seen malloc, calloc, realloc and free, right? Those things are used in order to fix this issue. But then it's a whole hectic task and you need to write extra lines of codes every time you are using an array. This is the reason why we use the concept of linked list. So in linked list what happens is that the arrays, we don't use arrays in linked list, but in linked list what happens is that it's a dynamic data structure. It is linear though, but also it is a dynamic data structure. Dynamic means the size is not fixed. In this case the size is dynamic. It keeps on changing as you keep on inserting the elements or deleting the elements. Automatically it takes care of the size, so you don't have to worry about the size in the linked list. So this is one thing that you should be knowing about the concept of linked list. And basically what we are doing here is we are saying that the size is dynamic in this case. So that means what happens is that you don't have to worry about the size being fixed. You don't have to write extra lines of code again and again. Why? I will explain you in a moment. Let us start with linked list concept. So as I told you that linked list is a linear data structure and it is of dynamic size. It is of dynamic size. Now let us understand a little bit more on how this works. So if I tell you about how the linked list concept works, let us see right here. So a linked list concept works like this, where this boxes I'm going to create, these boxes I'm going to create, and these boxes will represent the data, or in this case the technical term is called as node. Okay, this is a node and this is a link which is connected to another node. So this way this and this node are connected to each other. Similarly this and this node are connected to each other. This node and this node are connected to each other, and hence a list of nodes are created. Hence the name comes linked list. List of what? List of nodes. Understood my point? And what are nodes? Nodes are a entity which holds data. Okay. Ultimately, on the very first day, I have explained you about what is DSA. DSA, data structures and algorithm. I have explained you there that it's a data organization. Data organization. That means we are playing with the data, and node is an entity which holds the data. So basically, linked list is a list of nodes holding the data in such a way that you can create a collection of data and you can use it for your own purpose. It can be used for many different places. We have learned about stacks and queues. You remember, both stacks and queues can be implemented using linked list, and linked list has its own advantages and features which comes better in terms of rather than using an array in terms of stacks and queues. Linked list helps us a lot in different things. So let's talk about that in a moment. So here I am not gonna rub this out, but I'm just gonna move it so that you understand clearly. Let's create a linked list properly. Now before I go ahead and create a linked list, I want to tell you about some types of linked list. Now there are many types, but the most commonly and the very much popular ones are: number one, singly linked list, then we have doubly linked list, we have circular linked list. Then inside all of them comes many different categories, like for example you can have an ordered linked list, or you can have unordered, you can have again more categories, sorted or maybe unsorted. Are you getting my point? A lot of things can be covered in terms of linked list. So basically, majorly there are how many? Singly, doubly, circular, and we are going to talk mostly about doubly and singly basically. So these are the different types of linked list that are available to us for us to use into our concepts and create a collection which allows us to do a lot of things. Let us see more on this. So now we are gonna actually see the proper difference. Let's start with our first one, and singly linked list. The first one is singly linked list. Let me create it from here. Let's say this is my singly linked list. Let's have 4 nodes. You know, a singly linked list looks like this, where we have understood that this is a node, this is a link, this is a node, link, node, like that. Now what happens in singly is that a node is divided into 2 parts like this. A node is divided into 2 parts. The first part is the place where you store the data, and the next part is stored the next pointer. You see, what is this next pointer now which I am saying? Next pointer is a pointer which points towards the next coming node, which stores the address of the next coming node. You see, I told you in the beginning that linked list is what type of data structure? It's a linear data structure and it is dynamic in size. That means, what does this mean? You see, an array contains so many partitions, but an array has only one single large block of memory. Okay, array is one single large block of memory partitioned into many different parts, and this is the reason why it has fixed size. Are you getting my point? It has fixed size. This is the problem here. So to fix this problem, now what happens is, in the linked list is a dynamic data structure. Every single node will have its own memory allocated. That means memory is allocated on the go when you create a node, meaning we will use DMA, dynamic memory allocation, while we are creating the node. How we will be creating the node? In a moment I'll get to know about that. I'll explain you how to do that. Let us continue a bit and we'll understand that. That means I told that every single node in this case will be containing the own address. If basically in every node, if every node is holding its data and it has own memory allocated, that means it will have some address. So let's say I'm going to take up random addresses like 2187. I said 2812, 2918 and 2312. I took some random numbers representing that every node has some memory address, and these numbers are not actually the numbers, these are addresses. Addresses are stored in hexadecimal value. So hexadecimal value, if I am writing here, it will get confused, so I am going to explain you in numbers. So that means here I told you that the data is stored, so let's say 10, 20, 30 and 40, the data is stored like this. But now if this node is connected to this node, then this next pointer will hold the address of the next node. So 2812, this address will be stored right here. Similarly, this address will be stored right here. That means 2918. That means this address will be stored right here. That means 2312. and here because it is the tail node or the last node, this next pointer will be pointing towards null. Null means there is no node connected in front. Understood? This is very much clear. Now, one thing, this can be an ordered or unordered. This can be an ordered linked list or unordered linked list. So, how we will get to know that which one is the first node? This can also be the first node. This can also be the first node, or this can also be the first node. So, to know about which one is the first node, you know, there is a concept in linked list, an attribute of a linked list, and that is called as head. Head. Okay. Head is a pointer. Head is what? It is a pointer which stores the address of the first coming node, the very first node. So, in this case, head is not a node, guys. Number one point. Head is not a node. Head is not a node. Okay, head is a pointer. A pointer always stores or point towards a particular node. That means the address will be stored here, and head means the very first thing. That means the first node's address is stored here, and if the first node address is stored here, that means 2187 is stored here. That means this head pointer points towards the first node, which tells us that that node is the first node. Are you getting my point, guys? It's way too easy. If you know what are pointers, if you know what are dynamic memory allocation, if you know object oriented programming, you will be able to do linked list in C++ in the easiest way possible. But the prerequisite, as I told you before beginning this live session, I have explained you that you need to understand that. So, if you haven't still watched that, I recommend you to watch that first and then come to this live session, but you will understand about, then you will properly understand about how this concept works. Alright, but anyways, let's continue. So, this is our linked list. Now, the best part of this linked list is that it is dynamic, means I don't have to worry about the size anymore. I don't have to even worry about, because every element is having its own memory address. I don't even have to worry about if I want to insert anything in between. So, for example, here I said I want to insert 100. So, what I will do is I will create the 100 as a node. I will create a node where I will store some 100, and here 100, this is a node. So, node will also have its own address. So, let us say 13172 I said is the address of this newly created node. I want to add in or insert anything. What I will do is I will just disconnect this link and I will say you get connected here and you get connected here. That means this address will be stored here and this address will be stored right here in this case, and there you go, connection is made and you have inserted an element in between. This is the thing which you should know about. Now, that's an advanced concept of how to insert an element into the linked list that I am going to talk about later on, but a lot of features are good in linked list that you can use. And the very first thing that in today's live session we are going to explain you about is how to implement a linked list first. Inserting the a node into a linked list and creating a linked list is another thing. So, let us see till where we can discuss. Let us start. So, my first question to you guys is how you can implement a linked list. How you can implement a linked list. To implement a linked list, it's very simple. First, create node. Create node. How to create node? If you are doing C programming, you will use structures. If you are doing C++, you will use classes. Okay. So, create a class called as node. Number 2. First, you need to create the node. Number 2, insert nodes and create a linked list. Understood? Number 3, now you can perform operations to do for some particular thing. Maybe you are creating, example, you are creating a stack out of it, or maybe you are creating a queue out of it, or maybe you are using for graphs, algorithms, etc. etc. These are some of the uses of linked list. So let us talk about the very first one, how to create a node. It is very simple, guys. To create a node, what I'm going to do is, if I want to create a node, then what I'm going to do is, as I told you here, create a class. And to create a class, what I will do? Class node. Okay, I have created a class node. Inside this, what are the attributes of the node? Data and next pointer. So in this case, the node will have data and next. That means I will say int type of data, because our data is 10, 20, 30, 40, you can take anything as a data type of that particular thing. But in this case, here our data is 10, so I am going to take int data, there you go. Then I said next pointer. Now next pointer. But what will be its data type? Guys, if you have seen our pointers video, I have explained you about the two types of pointer, typed pointers and untyped pointers. Untyped pointers are the void or generic pointers, and typed pointers are those pointers which will have some type. For example, int, char, boolean or class type of pointer. Here we are going to use class type of pointer. So if you haven't watched that video, please go ahead and watch what are typed pointers. I have already created a video on what are typed pointers and how they work. We are applying that here. See guys, this is DSA course that we are doing, and in this course we cannot again and again go back and learn all the things which we have done it in past. So in this case, you need to come prepared, and in every live sessions we can't just start and go ahead and teach all pointers and object oriented programming again from the beginning. And that is the reason why I am again and again asking you to revise or do the prerequisite and come. Because again, if I write here something, you will not understand it properly. And this is where you will lose interest in the concept, like linked list. And to not lose the concept, this is a very interesting concept this is. And you see, there are a lot of interview questions and lead code problems are there from DSA and linked list that can get you a job. So this is equally important for us. But basics is something which we should always know, and for that reason I am using that. Basics, we have already done this before, so let's just continue, and let's continue here. So what will be the data type of the next pointer? It will be a typed pointer, not a void pointer. It will be a typed pointer, and the type of this node is going to be this. Next is going to be node. This node and this node is the same. Think about that, guys. You're talking about this pointer, this. It is storing the address of the next coming node. Understand my point? This node, this next is storing the address of next coming node. And if I'm talking about next coming node, I'm talking about this whole node. That means this should be a pointer which should point towards this node. And how this node is created? Tell me guys, how this node is created? How this node is created? This node is created using the same node class? No. So the next pointer will point towards the node class object, which is the next node. And this is how you will get this data in here. Are you getting my point? That is why we say that the next pointer will be of type node class. And that's it. These are the two attributes that you have written. And we have studied an OOPS concept in object oriented programming in C++ already. That whenever you have attributes, you create a constructor. So I said constructor. So people who don't know what are constructors are the specialized function which will never have a return type, because they are used to construct something. And what is that? Object. Constructors are going to have the same name as the class name. and this is your constructor. Well, when we will be creating the node, this constructor will be called, because node is the object here. So constructor will be called there, and for that reason we need to choose our parameters very wisely, because we know that from object oriented programming constructors class, we know that constructors, they create the object and they do initialize the object attributes. And what are the attributes? Data and next. So in this case what we will do, we will create a constructor and the attributes will be taken as int data. Now you might say, sir, write node star next also, but no, this is wrong. We won't say this parameter here. Why? Well, think about it, guys. When the object or the node will be created, constructor will be called, and if you write this as a parameter, of course it is going to ask the address or the value of this as well. And do you know the address of a node which is not even created yet in a program? No, right? That is why you skip it. You don't write it anymore. You just say data. You leave this like that. You leave it like that. What type of pointer, guys, this is? This is wild pointer. Wild pointer. And we have understood from our pointers class that if a pointer is wild, we need to neutralize it. And to neutralize it, we need to make it as a null pointer. So we need to initialize that pointer to null. And to make it null, we use constructor. That means inside this, we are going to say this dot, not dot, arrow. In C++ we use arrow, in Java we use dot. So this arrow data equals to data, and this of next, which we have created here, equals to null, capital null, or that is C syntax, and C++ says nullptr are the same. And this is how you neutralize a wild pointer. And guys, congratulations, you have created a node with the help of this node class like this. You got my point? Understood this very clearly, guys? Very important concept. And this way our first step is over, and that is creation of node. Let us write the code for it and understand how it works. I'm going to go towards my computer. Right. I hope my screen is visible. Let us just start coding. Correct. So, right. Where do we start from? We start from hash include iostring using namespace std. Correct? And then we create our main. Now I know there is no use of main right now, but I'm just gonna create it and keep it like that, empty. Until the time comes, I'll continue writing in this. So what I'll do is, I'll create a class. So our first step was to create a class. So I said class, what was the name of the class? Node. Are you getting my point? So class node. And now what I'm going to do is, what are the attributes? Int data and node star next. Achha, one thing I have forgotten to write, and what is that? Public. Access specifier, until and unless you write access specifier, your object will not be able to access anything, because objects are going to create in the main or in the different scope. But if those objects are not able to access that, then what's the use? So public is very important. This public right here is very important, guys. Understood? Then we start by creating our constructor. Constructor is the same name function of the same name as class name, and it is never return type, so we write it like this. I hope so that this is very much clear. This of data equals to data, and this of next equals to nullptr, and a class ends in a C++ with semicolon. And there you go guys, this is a class which will allow us to create a node. Understood my point? Is that clear to all of you guys? Correct? Now what I'll do is, I will do one thing. I want to create a node. That means our blueprint is ready. Our class blueprint is ready. This. So what I'll do, I'll go to the main and I'll say create the object of this blueprint. Create the object. Now how do I create the object, guys? One more thing now I want to tell you. And what is that? That I told you that here every node will have its own memory, correct? Because it is a dynamic data structure, and if every node has its own memory, if it is a dynamic data structure, then what happens? In every single node you need to do DMA, dynamic memory allocation. You have to use malloc or calloc, or malloc or calloc. But if you are using C programming, you would use this. But we are not doing C, we are doing C++. And if we are doing C++, then what we will use? We will use new keyword. Are you getting my point? So I am in the main function right now here, and I want to create a node. So I'll say node star. The new node is going to be a pointer. So I say node star n equals to, and I'll say new and then node. Like this I'm going to create the data, like the node. And here I'll pass the data. Let's say 10 is my first node. Understand the point? What does it says? No instance of the constructor node matches with the argument list, argument types of int. Acha, why this happens? Why this happened? Wait a second, guys. Alright guys, actually there was a technical issue with the camera, so now it's back again, we are live again. Yup, okay. I hope so that we have understood this really well. So here we have, what we have done is, we have created the node class, and this is our public int data and node star next. One thing, I have done a mistake here. You see, when I was passing this 10, it was not taking anything because I have not given any argument here. Can you debug the code? Int data has to be given, correct? So now what happens is, this 10 goes right here in this data. Now actually, let me draw this over here so you will understand this much better. Okay. So now you see guys, what exactly happens here? This is our argument 10. This This 10, what is this? This is a constructor call. This is what? A constructor call. And who is the constructor here? This guy is the constructor here. This means this constructor is getting called. That means this 10 is the argument for this particular parameter. That means this 10 travels to this data. And then what happens is, that travels here. That travels right here. and then what happens? It travels right back here, and this data means this data. Understand my point? You understood? Let's do it again. Let's create all the links again, but I'm going to do it with the new color. Let's take red. 10 goes right here in the constructor call. 10 goes right here in the constructor call, which means it will come here. This will go here. Understand my point? Which means this data is actually this data. Now you got my point? So with this, we physically created a node dynamically allocating the memory for the data and storing 10 right here. And you see that if I have not provided anything, because it was not accepting anything, next was automatically null. Understood my point? For that node, because of course this is the object of the node class. Understood my point? Node class. That means in the memory you have created this. If I want to create a new node, what I'll do? I'll say node star n. Let's say if this was n1, this was n2, equals to new node, and I've said, let's say 20. We have created another node using the blueprint class node. Understood my point? That means, oh, I have not unpaused it. Sorry guys. You see, I have created, wait a minute, I'm sorry. I have created another node like this, and what happens is that this is the constructor call again. N2 is another node, and this is the node class. That means in this case also, what happens? This 10 goes here, which means it goes here, which means it goes here, this means this go here. Similarly, 20 also goes into the data. Data is set to here, and which is means 20 will set to be this. So in the memory there are two nodes created. One is 10 with null, and there is another node called as 20 with null, but they are not linked to each other right now. We have separately created 1 and 2 node. We have not linked them. So still it is not a linked list, but it is just a node right now using the node class. And if I want to create this as a linked list, what I'll do? I will have to write a function. What function? Insertion function. Insert function. An insert function can happen in 3 places: insert at head, insert at tail, and insert at a specific position, which is another concept in itself, guys, which we will do in our next live stream. For today, let us keep it till here. You also should get some time to understand and revise these concepts. Go try it on your own and understand how nodes are working and creating. You see, I have used DMA in C++. This is dynamic memory allocation. Understand. If you have not understood what is this next pointer, go watch our pointers video. This is a wild pointer. Understand my point? So understand and come in next live stream where we are going to discuss about these 3 concepts all at once, or let's see if the time allows us or not. Well, I hope so that today's live session you have understood this really well, and this is the program that we have written. We will not disturb this program and we will come on to our next live stream, and then we will understand about how this works. Are you guys getting it? So that's it for this live session, guys. Thank you so much. I hope so that if you have any doubts, you can please ask me. There are no doubts that have been asking. So I believe that there are no doubts in the program, and I hope so that you have understood this really well. Thank you guys so much for joining us. and I hope so that you have understood this linked list concept really well. If you have any doubts, you can still ask me in the comment section below, and yep, that's it. Thank you so much, guys. So this is Ashank David signing off. I will see you guys in the next live stream. Next live stream I will plan accordingly, because I don't know what will be the next time, or what will be the next thing that will happening. So I'll be updating you guys on the social media as well as on the YouTube community as well. So that's it for this live session, guys. This is Ashank David signing off. Don't forget to like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Well, that's it. Thank you guys so much for watching, and I'll see you in the next one. This is Ashank David signing